Chapter 3 test will have two parts, a graphing calculator part and a no calculator part. On the graphing calculator part, you can use a graphing calculator. If you want to have a regular calculator sitting with you as well, you may do that also. On the no calculator part, you will get to use your pencil and a brain and no calculator at all. Now, with each part, these numbers here along the side, this in parentheses, the 4 to 8, the 2 to 3, those are the approximate number of questions that will be on the test. As we go through these things, these bigger numbers here and these letters here are representing the problems that we do in this review. The no graphing calculator, or the no calculator part, will be the first part of the test. So this will be taking place on Thursday. The graphing calculator part of the test will be the second part. And so that will be on Friday. So as we go through this, we're just going to go through these slide by slide. And so these first ones here, we are trying to solve the equation for x. In this first one, first thing you would need to do is subtract 9. And you would be left with a negative 5e to the negative x equals negative 3. Second thing, you would want to get rid of the negative 5 by dividing by a negative 5. And you would be left with e to the negative x equals 3/5. Next thing would be you need to get the x out of the exponent, so to get rid of it, the base, since it is e, you will have to ln both sides. And then you will have a negative x equals ln of 3/5. And you can figure this out at this point in time if you want to, or you can just wait. And then the last thing would be then to divide by a negative 1. And so your final answer would be x is approximately equal to negative ln of 3/5 which is 0.5108 approximately. Our second example. First thing you would have to do is add 4. And you would get 3 to the 0.1x equals 9. Then to get the x out of the exponent, just like here, you have to logarithm both sides. With this one, we had to log base e, so we ln. Here we have log base 3 to do to both sides. And you would get 0.1x equals, and to figure out what log base 3 of 9 is, you can do log of 9 divided by log of 2, or log of 3, which is 2. Or you know 3 to what power is 9. Either way, that is fine. And finally, divide by 0.1 to get x equals 20. Our next example. 1/2 log base 6 of 16x equals 3. You could move this to the exponent and put that all in parentheses to the 1/2 power and then go from there if you would like to, but you can also just multiply both sides by 2 first to get rid of it, and then you would have log base 6 16x equals 6. It's not going to make any difference which way you go. One way may be a little easier than the other. So we're going to just continue on in this method because I think this would be the easiest one. Then to get rid of your logarithm, you need to, remember, rewrite this then as an exponential equation. And our 6, this 6 becomes our base. This 6 becomes the exponent. And what it equals is 16x. That's your base, that's your exponent, that's what it equals when you rewrite it as an exponential equation. And then finally divide by 16 on both sides. And you will get 2,916 equals x. And this is an exact answer, so we can put an equal sign. Whereas the previous two were an approximation. Actually, the first one was an approximation. So you put approximately equal to, and the second one wasn't exact, so you can put an equal sign. All right then, our next one. First thing, subtract 7. And you will have 2 ln of a negative x equals 7. Then we would divide by 2 to get ln of a negative x equals 3.5. And then just like with this one, we need to rewrite as an exponential equation because we see ln. We would then have e to the 3.5 equals negative x. And finally divide by a negative 1. And you will get x is approximately equal to negative 33.115. Now, this next question. If this were not here, and we just had ln of x plus 5 equals ln of x minus 1, you can just drop the ln's and set x plus 5 to equal to x minus 1 because they are equal. And then just solve x plus 5 equals x minus 1. But that is not the case. We have two things on this one side. So what you must do first is condense this down to one expression. So ln of x plus 5 is not going to change. Ln of x minus 1 plus ln of x plus 1, because it's addition in between and you're going to condense this, you would then end up having to multiply. So you would get x squared minus 1, because you're multiplying x minus 1 times x plus 1. Now that you have it written this way, because both of these have ln on each side, they can be gotten rid of, and you will be left with x plus 5 equals x squared minus 1. And so moving things to the same side so that you can have one side equal to 0, you will get 0 equals x squared minus x minus 6. And then you need to solve this equation. If it is not factorable, you can turn to the quadratic formula. This one, however, is factorable. It is x minus 3 and x plus 2. That equal, because multiplied those get you negative 6, and if you add those, they get you negative 1. So then, in this case, x will equal 3, and in this case, x will equal a negative 2. And with any logarithmic equation, you need to make sure you check it to see if these actually will be okay in the original problem. Remember, because any logarithm with a base or ln, the domain for it has to be greater than 0. So that means this part has to be greater than 0 in all three cases. When you substitute a 3 in, 3 plus 5 is 8, which is greater than 0, so it's okay there. 3 minus 1 is 2, which is greater than 0, so it's okay there. And 3 plus 1 is 4, which is also okay because it is greater than 0. Substituting a negative 2 in, a negative 2 plus 5 is 3, so it would be okay there. A negative 2 minus 1 is a negative 3, and you cannot take the ln of a negative 3, so therefore it's not going to work in the problem. So this one gets crossed out, and remember, it is called an extraneous solution. And so we only have one solution, and that is x equals 3. Now then, you'll also be asked to graph some things, maybe even state the domain and range. And so with this, if you were going to put this into your calculator, you just put 5 and then x plus 2, and you need to make sure that your x plus 2 is in parentheses if you don't have a calculator that puts it up in the exponent. This type of function is an exponential function, so when you're graphing it, it would look like this. That coordinate right there would be 0, 1 in this case. And the domain would be all reals, and the range would be all greater than 0. This second one is a logarithmic function, log base 3 of x plus 1. Now if you were trying to use your calculator to graph this, if you do not have a calculator that can put this base down here, then remember you have to use the change of base theorem, and you would have to put log of x divided by log of 3, and then plus 1. And you will get something that looks like this. In a logarithm function, the domain would be all greater than 0, and the range would be all reals. And remember, this is going to shift the graph up 1. And back to this other problem. This one that I drew here is not correct because I forgot about the a plus 2, which shifts everything to the left 2. So this is actually going to be over here like so. And this coordinate is not at 0, negative 1. It is going to be a negative 2, 1. Sorry about that from before. But like I said, to enter them, you can just enter and then figure things out from there. Anytime you have a logarithmic equation that you have to enter, use your change of base theorem unless the base is 10 or e. Then you can just use that button on your calculator. All right, with this one, you are going to have to enter this into the stat part of your calculator and then choose the most appropriate model. Your choices would be a logarithmic model, an exponential model, maybe even a linear one. It all depends on what you see and how they're graphed. If you look at it on the coordinate plane, 2, 8 is there, 3, 16 is there, and 4, 30 is there. So it looks more exponential than it does anything else. So then you would want to calculate an exponential model. Now, based on what type of calculator you may have this choice, or you may have this one. If you only have this choice, then that is fine. Your equation would be 2.15 times 1.936 to the x power. If your calculator only has this as a choice, then you would have 2.15 e to the 0.6609 x. They look slightly different, but not too much. They still have the same initial value. And if you actually take e to the 0.6609, you will get 1.936. And so that's how you would calculate an exponential model, just because it looks like it's exponential. If it was a logarithmic, then you would take a logarithmic model and then write your equation from there as well. Now then you also have some story problems dealing with all kinds of different things. In this case, we're asking how long for something to double at 7% compounded quarterly. Remember, when it's time to double or to triple or to quadruple or anything like that, it really doesn't matter what value you start with, because if you're going to double, it's just going to be twice that amount on the other side. So if you want, you can pick a value, but you really don't need to. Pick 1. And so then you would have 1 plus, since it's 7% compounded quarterly, it's 0.07 divided by 4, and then it's to the 4x power. And if we start with $1, we'd have to end up with 2. If you start with 10, it's 20. If you start with 100, it's 200. Even any way you look at it, when you divide, you're going to get 1.0175 to the 4x equals 2. And then to solve this, you would take log with a base of 1.0175 to both sides. And then you would have 4x equals log of 2 divided by log of 1.0175, because you have to use your change of base formula. And so then solving that, finally you'd have to divide by 4, and so x will equal approximately 9.988 years. Now then, they can also ask you to find one where it's compounded continuously. Same thing. Your initial value be 1, e to the 0.07 t equals 2. Get rid of the 1, and it's still that. And so now to get rid of e, you have to ln both sides. So then 0.07 t equals ln of 2. And then finally, you would divide by 0.07. And in this case, you would get x, or t, equals 9.902 years. Pretty close to the same amount. Now then, on the non-graphing calculator part, having to evaluate these things, this would be 2 to what power is equal to 1 over 32. Well, 2 to the 5th is 32, and so since it's the reciprocal of 32, then it's going to be a -5 for an answer. Our second question, ln e to the 3x. Because ln and e are inverses of each other, they can go away and you're left with just 3x. Now with this one, 2 log base 2 of 5x plus 1, because our base and this base are the same, these two things are inverses of each other, so we would just be left with 5x plus 1. And finally, our last one here, it is saying 3 to what power is 9, and that is 2. Second thing you'll have to do are similar to those two questions on that last assessment, where you're going to be given two logarithmic values, and you have to figure out how to come up with the answer to these types of questions. So log base A of 45. 45 is the same as saying log base A of 9 times 5. And 9 is the same as 3 squared. So then you would have 2 times log base A of 3 plus log base A of 5. And since we know that log base A of 3 is 0.6826, and we know that log A of 5 is 1.273, now you have to use your multiplication skills. Multiply this by 2, and then add 1.273. So 2 times that is going to be 12, 1, 5, 16, carry the 1, 12, 13, so 1.3652 and 1.3 or 273 then have to be added together. And you get a final answer of 2.6382. Second one, log base A of 9 is the same as saying log base A of 3 plus log base A of 3. Or you can say 2 times log base A of 3. Either way, it's 0.6826 plus 0.6826, or 0.6826 doubled, which is 1.3652. Our third example, log base A of 5a cubed. You can break this apart and say log base A of 5 plus log base A of a cubed. And because that's an exponent, this can be pushed to the front, so 3 times log base A of a plus log base A of 5. And we know log base A of 5 is equal to 1.273. And log base A of a is 1 times 3 is 3. So you will get a final answer of 4.273. Last example of this type would be log of a squared divided by 3. So that would be saying log a of a squared minus log a 3. And log a squared is the same as 2 times log a, and log a is 1, so 2 times 1 is 2, minus, and we know log base A of 3 is 0.6826. And then not having to use a calculator, you have to borrow and make that 9, and then a 9, and then a 9, and then a 10. And so then when you subtract, you will get 1.3174. So somehow, some way with these, you're going to use your expanding properties of logarithms and these values to come up with these numbers that they give you. Now then I'll also ask you to expand just an expression. So to start with, because there's multiplication in between, you would say log base A of 3 plus log base A of x to the 4th plus log base A of y. And so then you can move that to the front. So we'd have log base A of 3 plus 4 log base A of x plus log base A of y. And you'll be asked to condense one as well. So to condense, we've got to get it down to one logarithm, log base 3. Here we have 2 plus 5 times x, log base 3 of x, and that becomes the exponent, so it would be 2x to the 5th. And minus means we divide. The 2 becomes the exponent of the y, so it would be over y squared. Now if you had something like this, 1/2 log 3x plus 2 log 3y, that would be log base 3 of the square root of x, and then y squared. And finally with this, if these things were in parentheses like so, it wouldn't change anything because that's an addition sign outside of there. It's still going to be that 2 times, and then you'd have x over, this would change to log base 3 of x to the 5th over y squared. And then if you multiply by 2, you're still going to get that. And finally, you'll just have to select some graphs and pick out which graph is which type of function. So if we were dealing with ln x, because it's a logarithmic equation, you should understand that the domain is greater than 0 and the range is all. And it crosses, since there's nothing with it, it's going to cross at the coordinate 1, 0. So it is going to look like this. And this coordinate is 1, 0. Since our base is e in this case, that means this coordinate out here is going to be e comma 1. Our second equation here we're going to look at is log base 3 of x plus 2. Because we have a plus 2 here, that is going to shift it to the left 2 places. So instead of it typically being here and going through 1, 0, it's going left 2 places. So 1 to negative 1, 0 is when it's going to go through. It's going to come up and do that. And finally, our last one here, negative log base 4 of x. Because the negative is on the outside, that's going to flip it over the x-axis. And the log base 4 of x normally would go here, like so. But now it's going to be flipped. So it is going to do this. Because that negative sign flips it. And finally, our last one is y equals 2 times 3 to the x. That is different than these three in that it's an exponential function. And exponential functions run along the axis and then curve upward. And that coordinate right there, because we have our initial value is 2, that coordinate is going to be 2 comma 0. And this is greater than 1, so therefore it's a growth function, which makes it look that way. If this number here had been less than 1, so like 0.5 or 0.75 or something like that, then our graph would have been a decay function and done this and still run along the x-axis. And that concludes our Chapter 3 review.